Let's continue with whatever we have stopped in the last video. See the ninth one? A rectangular sheet of tin 45 centimeter by 24 centimeter is made into a box without top by cutting off square from each corner and folding up the flaps. What should be the side of the square to be cut off so that the volume of the box is maximum? Alright, see here, you have a rectangular sheet of tin, whatever it is. Let's do this one. You have the length and the breadth, correct? The length is 45 centimeter and the breadth is 24 centimeter. Now, this is made into a box without top, correct? By cutting off square from each corner and folding up the flaps, right? Now, box is cut. Basically what they're telling, so you have a rectangular tin sheet, correct? Now, you're cutting off square from the sides, in the sense you're cutting off one square, one square, one square and one square, and then you are, see, you're going to flip this one, flip this one, flip this one and flip this one. So basically it's like this and like this, correct? So that is becoming a box which is open on the top. Now what they're saying is, what should be the side of the square? So call it as maybe x. What should be the side of the square so that the volume of the box is maximum, right? See, volume of the box, it is a cube, right? Since it's a cube, cuboid. Volume of a cuboid is L into B into H. Wow. Now, volume is equal to L into B into H. Now, let's try to understand that when you have L into B into H, what is the height, what is the length, what is the breadth, whatever. Like we'll get in terms of X. That's all. Alright. See here, if this is X, try to visualize this one. Okay, so try to visualize this. Let's make this a little more easier for you guys. Okay, now guys, look at this. So we have a tin sheet. So exactly like this one, 45 centimeter by 24 centimeter. And you have 4 of these things, correct? Now what they're asking you, or what they're telling you is, we are going to cut this one, cut this one, cut this one and cut this one. Alright, so we are going to cut all 4 sides and we are going to fold it to make a box. Alright, now see how the box will look like. The cuboid is going to look like this. See this one? Now what exactly here we have? So we are going to remove this one. See, the squares have been removed, correct? Once the squares have been removed, so this part you are going to fold, this part you are going to fold, this one folding, this one folding. So when you fold, the cuboid, the open box is going to look something like this, right? Now remember, what we need is, we are trying to find this volume should be maximum, right? So volume is what? Length into breadth into height. So L into B into H. Now when you have L into B into H, so what you need to understand is that, see, this particular length is nothing but the side of the square, correct? Now when you open this, the entire length was 45. I removed x, removed x. This is nothing but 45 minus x, correct? Now this is the breadth. This breadth, the entire breadth was 24, like this entire breadth, of which we removed x, That's going to be 24 minus 2x, right? So what we can write now is that the new length, you can write this as L dash. So L dash is equal to 45 minus 2x. B dash is equal to 24 minus 2x, isn't it? Now the height is nothing but the height of the square itself. Like if you take it like this, see, this is the height of the square, like this one, isn't it? So this part what you're seeing here, this is the height of the square. That's nothing but the height of the cuboid itself, right? So we can say that the height h is nothing but x, correct? So what do we get now? We have L value and we have B value. That's fine. Now we have L dash, B dash and H. Now they're asking you what should be the value of X. This is the question. So what do? Find the volume. So V is equal to L dash B dash into H. So 45 minus 2x into 24 minus 2x into x. Right? Now you can multiply this. That would be an easier way because you have to differentiate this, right? Differentiate with respect to x to get the values. What should be the value of x and all. That's what we are trying to do. Anyway, so first you can multiply. First it's going to be 45 into 24. You get 1080 minus 90x minus 24 into 2 is 48. 48x plus 4x square. The whole thing into x. Right? So you can multiply 1080x minus, see, minus 90 minus 48, which is same as telling 90 plus 48, correct, which is 138. So 138x square plus 4x cube. See, this is the value of V, volume. Differentiate with respect to x. So what we have now is you're going to do dV by dx, which is 1080 minus 138 into 2, which is 276 plus 12x square. Guys, now we need to equate this to 0, get the value of x, isn't it? So let's do that part now. See, you have dV by dx, 12x square minus 276x plus 1080. Remember, you have to equate it to 0, correct? That's how you have to find the points of inflection. So when you solve this, you'll get x value as 5 or x value as 18. You guys can use the formula. Splitting the middle term, I would not recommend that. I mean, even though you can take 4 common, you can do it. But I would always suggest taking the formula in these cases. Okay, simplify and then apply the formula. So we have x as 5 and x as 18. Do second derivative. Okay, second derivative d square v by dx square. 24x minus 276. Right? Now, put x as 5 first. Take x is equal to 5. 24 into 5 minus 276. So this is going to be, so 24 times 5. So you have 120 minus 276, which is clearly less than 0. So we got a value of x is equal to 5 where the double derivative is negative. That means you know that that is the value where you are going to have the maximum volume, because x represents what? X is the side of the square. So what we can conclude, we can say that for x is equal to 5, the volume is maximum. Volume is maximum. Therefore, the side of the square is 5 centimeter. So this is going to be the final answer. Clear? This is how you need to solve it. Now, for the first one, I tried showing you the figure so that you can imagine, you can visualize it. Fair enough? So second one, I want you guys to try and visualize it by yourself so that it's going to be a little challenging for you. Fine? Let's do the next one, that is the 10th one. See, in this question, show that a right circular cylinder. So first what we'll do a right circular cylinder, small cylinder of given surface area. So surface area of the cylinder is 2 pi r into h, and maximum volume is such that its height is equal to the diameter of the base. Volume is pi r square h is such a way or is such that the height is equal to diameter. So h is equal to 2 times of r into 2, isn't it? So the diameter is equal to the height, that's 2 times of r. So now what we are going to do, we'll do this one. It's quite a simple one actually, because they've told that maximum volume is already maximum, you know that. That means second derivative is going to be lesser than 0, right? So first, let's do take volume. V is equal to pi r square h. So dV divided by, now what we are going to consider, we'll take dV by dr, okay? You can take dV by dH also, but we can take this one. Or rather, you know what, rather than starting with this, let's write in terms of the surface area itself. Because they're telling given surface area. So when they say given surface, it's constant, right? So what do we have? S is equal to 2 pi r into h. Now substitute in the sense, let's take r is equal to s divided by 2 pi into h, or rather h is equal to s divided by 2 pi r, correct? Substitute the value of h in the volume function. So you have v is equal to pi r square into s divided by 2 pi r. 1 r and r cancels. Pi and pi cancels. So you end up with v is equal to s into r divided by 2. So now you do dv by dr is equal to s divided by 2. Correct? Now when you have s divided by 2, now what we are going to look at. So you know that the volume change, whatever we have dv divided by dr, rate of change of volume with respect to radius is giving me s divided by 2. Correct? Now you can take it in two ways. Fine. So one of the ways what you can do is you can substitute s as 2 pi r h. Alright, so you will get in terms of r and h, you can further differentiate. Alright, or there is another way. So we'll look into the other way. Alright, so another way what we have is, see the 10th one? Right circular cylinder. So you have a cylinder like this of given surface area and maximum volume such that height is equal to the diameter of the base. Fine. So when they say surface area, we need to take the total surface area. Okay. So TSA of a cylinder is given by 2 pi r square plus 2 pi r h. Correct? Now, this is surface area and they're telling you that this is constant, this is given. Now, what you do? Take 2 pi common. 2 pi into r square plus rh is equal to s, or r square plus rh is equal to s by 2 pi. Call it as some constant k. Okay, so this is a constant value. Now volume V is equal to V is equal to pi r square h. Correct? This is the volume of the cylinder. So when you have V is equal to pi r square h, now what you can do, you can differentiate this and you can get it, or without that also, without that in the sense substitution way you can get it. Alright. So now let's look at the next method. So what we'll do, we'll substitute for h. That means, see, look at this equation. That is RH is equal to K minus R square, or H is equal to K minus R square divided by R, right? Substitute that value here in the place of H. See what you will have, you are going to get V is equal to pi R square into K minus R square divided by R. So 1 R and R cancels. So V is equal to pi into KR minus R cube. Differentiate. dV by dr pi into, so this is going to be k minus 3r square. Equate this to 0, points of inflection. So what do you have? Pi, see, pi can't be 0. So k minus 3r square is 0. 3r square is equal to k. So r is equal to root of k divided by 3. R is root of k by 3, correct? Now, they've told you that volume is maximum, so you don't have to substitute again. So what you do, you substitute this back in the equation so that you can figure out the value of h. Substitute. That means, in this case, what you're going to get, h is equal to k minus r square is k by 3 divided by root of k by 3. Correct? So h is equal to, if you take LCM in the numerator, you'll get 2k by 3 by root of k by root of 3, or h is equal to 2k by 3 into root 3 by root k. So can we write this as h is equal to 2 times root of k by 3? Isn't it? Root of k by 3. But what is root of k by 3? R. So can we write this as 2 times of r? So what do we get? H is equal to 2r. 2r is nothing but what? Diameter, right? So this implies h is equal to d, the diameter. And that's what we are trying to prove. Alright, that means h is equal to d. The height is equal to the diameter of the circular cylinder. Let's do the next one. See the 11th one. A wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made from into a square and the other into a circle. What should be the length of the two pieces? The combined area of the square and circle is minimum. Double derivative, it should be positive. So here, now what you have here, the total length of the wire, let's call it as capital L. So capital L is equal to the first made into a square, the perimeter of a square, 4 times of S plus 2 pi R. Right? Now what we'll do, so we can take this particular value. This is what we have. One of the pieces is made into a square, well and good. Now the area becomes S square plus pi R square. This should be minimum, right? So first what we'll do, we can take L minus 4S divided by 2 pi. This value is nothing but R. Like if you're making R as the subject of the formula, substitute that in the area formula. So what you have, A is equal to S square plus pi into L minus 4S by 2 pi whole square. Right? Now you'll get A is equal to S square plus pi into L minus 4S whole square by 4 pi square. Pi and pi cancels. Differentiate with respect to S. Okay, so if you differentiate with respect to S, dA divided by ds is equal to 2S plus 1 by 4 pi into 2 because of the power L minus 4S into minus 4. Yeah, so 4 and 4 cancels. Now what do you have? 2S minus, because of the minus sign, 2 by pi into L minus 4S. You equate this to 0. Yeah. Now, once you equate this to 0, take off the 2 because 2 is common anyway. That means you will get 2S is equal to 2 by pi into L minus 4S. 2 and 2 cancels off. What you need is basically the value of S, correct? So, S is equal to L divided by pi minus 4S divided by pi. Now, take the 4S by pi on the other side. So, you will have S plus 4S by pi is equal to L by pi. take the LCM. You get S pi plus 4s by pi is equal to L by pi. Cancel off the pi. So you have S into pi plus 4 is equal to L. S is equal to L divided by pi plus 4. Now we got the value of S, right? Now what we actually need, so we are going to do the double derivative because double derivative should be positive, isn't it? Only then you can say that, yeah, this is minimum, correct? Now, again, what did we do? So we calculated the first derivative, correct? So what do we have? dA divided by ds. Let's take it in a normal way. That means you have, so what did we do? We started with s square, so you have 2s, correct? Plus the next part was L into, or just take it normally. In the sense you are going to have pi divided by, so we did 4 pi square, sorry, 4r square we did, 4 pi square into L minus 4s. So whole square was there, so 2 into minus 4. So we cancelled the 4 and 4, 1 pi and pi, right? Then what did we do after that? So we took this as 2s minus 2 into L minus 4s. This was the first derivative. Now let's find the second derivative. The second derivative will be d square a by ds square 2. See, you can take minus 2l, like, you can multiply and do it, plus 2 into 4. Basically 8s you have, 2 plus 8, which basically is 16 greater than 0, right? So what do we get? So 16 is greater than 0, obviously. So the combined area, see, we are getting the second derivative to be greater than 0, right? Since the second order derivative is greater than 0, so what can we conclude from this one? We can conclude that for the value of s, whatever we have got, we can say that the area of the square and the circle combined together will be minimum. So what is the length? What did we get? So we got the length side of the square is going to be L divided by pi plus 4, and the radius, whatever we have, R, is going to be, because the wire of length L is cut into two pieces, right? So one will be side of the square is this. So the entire perimeter is going to be this multiplied by 4, correct? So the radius, whatever we are going to have, will be 28 minus L by 4 plus pi. So the circumference is going to be 2 pi into 28 minus of L by 4 plus pi. See, no point in doing the LCM and simplifying, not required. Just keep it this much. That's good enough. Fine. So this is going to be the final answer. This is L. This is going to be the final answer.